This is Northern Oklahoma College Algebra Math 1513, Chapter 1, Lesson 4. We're going to solve equations with rational exponents or fractional exponents. That just means the exponent is a fraction. An example would be x to the 1/2 equals 5. That's going to be one of our examples that we work. And this is the fractional exponent they're talking about. So I'm going to show you how to deal with fractions in exponents. Okay, before we get started on our examples, we have to review quite a bit about square roots and fourth roots and cube roots and all the different roots we're going to take. Now let's start by talking about square roots. The square root of 81, we know that's 9 and negative 9. We know that has two answers because 9 times 9 equals 81, but also because negative 9 times negative 9 equals 1, not 81. So square roots are always going to have two answers. Now, remember that in the little corner there, we have a 2. We just never write it. The square root is a second root. And a second root, notice, has two answers. Okay, now look at the fourth root of 81. And we say the fourth root of 81 is 3 and negative 3, and that it has two answers because, if you'll look at my reasons, I forgot my arrow there, because 3, 3, 3, 3. If you use 4 3's and multiply them all together, you get 81. But also, if you take 4 negative 3's and multiply them all together, you get 81. So 81 has two fourth roots as well. So for this assignment, I want you to remember that even roots, and remember even are your numbers 2, 4, 6, 8. Okay, even roots have two answers. So if we have a root of 4, a fourth root, or a root of 2, a second root, which we call a square root, or a sixth root, or an eighth root, or a 10th root, if we have an even root, we're always going to have two answers, a positive and a negative answer. Okay, let's talk about odd numbered roots, like third root, and fifth root, and seventh root, and ninth root. If you look at this one, the cube root of 27 is 3. Because 3 times 3 times 3 equals 27. Then notice this one just has one answer, because a negative 3 won't work. And why won't a negative 3 work? Because negative 3 times negative 3 times negative 3 actually gives us negative 27, which leads into my next cube root. If I take the cube root of negative 27, the answer is going to be negative 3. For that reason. All right, following that same line of reasoning, if I was talking about the fifth root of 32, I'm asking myself what number used 5 times gives me 32? Well, that's 2, because if I take 5 2's and multiply them all together, I get 32. So we say the fifth root of 32 is 2. Using the same reasoning, the fifth root of negative 32 is negative 2, because the only way you can get it is by multiplying 5 negative 2's together. All right, the point we're making here is that odd roots, and odd roots are your root of 3, 5, 7, 9, etc. Odd roots have one answer. Okay, to illustrate this a little further, just look at these roots here. The square root of 64, now I'm going to go ahead and put the little 2 in there, even though we hardly ever do. The square root of 64 is going to have two answers, plus or minus 8, because 8 times 8 gives me 64, but also negative 8 times negative 8 gives me 64. The cube root of 64 is only going to give me one answer, 8, because the only way you can get 64 using 3 8s is to use 3 positive 8s. Moving on to the square root, I'll go ahead and put the little 2 in there. The square root of negative 64, remember we're dealing with i's here, so it's 8i and negative 8i, which we could also write as plus or minus 8i, either way. Two answers, because a root is even. If you see an even numbered root, you're going to have two answers on this assignment. If you see an odd numbered root, you're going to have one answer. And so when we take the cube root of negative 64, the only answer, whoops, back up to 8. How about we put the right answer there? The only answer on the cube root of negative 64 would be negative 4, because the only way that you can get negative 64 is by multiplying 3 negative 4s together. 4 times 4 is 16, times another 4 is 64. Negative times negative is positive, but times that other negative gives us a negative. All right, and change this answer up here if you were taking notes. That's a 4, not an 8. My bad. All right, so we're ready to look at our example for your problem number 43. So x raised to the 1/2 power equals 5 squared. Now what are we trying to do? We're trying to get x alone. That means I have to get rid of that exponent. Now what's the easiest way to get rid of an exponent? The easiest way is to raise it to another power. And the power you want to raise it to is its reciprocal. Now, before I forget, I want to raise this side to that same power. Okay, why are we raising it to the 2/1 power? Because when you raise a power, when you raise an x to a power and then raise it to another power, what you're going to do is multiply the exponents. When I multiply the exponents, when I multiply 1/2 times its reciprocal, 2/1, I get 1/1, which is just 1. So basically, by raising it to the 1/2 and then raising it to the 2/1, I have x to the 1. And x to the 1 is simply just x. So we eliminate the fractional exponent by raising it to its reciprocal. All right, let's go over to the right side here. And I'm looking at this 2/1. And really, since there's a whole number 2 inside the parentheses, I'm just going to raise this to a 2 instead of a 2/1. I'll just make the multiplication easier. Again, I have my 5. My 5 was raised to the 2nd power, and then it was raised again to the 2nd power. So when you raise a number to a power and then raise it to another power, you multiply the exponents, which gives us 5 to the 4th. Okay, let's back up. I'm reading my notes wrong, so I copied down the problem wrong. Hopefully you guys are writing in pencil. You ought to be. So erase this side of the problem. And I wrote down 5 squared, but I wasn't supposed to square the 5 yet. So there's the original problem. X to the 1/2 equals 5. I just read my notes wrong. And when I squared the left side, I squared the right side. So I raised the x to the 2/1 power here. But over here, I just call it a plain old 2 because it'll be easier, raising 5 to the 2nd power. All right, so we have x to the 1 equals 25. In other words, plain old x equals 25. Okay, a question we have to ask ourselves is our answer a plus or minus 25? Is it just 25 or is it a plus or minus 25? Well, we have to go back to the problem and see what root we took. Remember, this number here on top, that's the power you're raising it to. And the number on bottom is the root you're taking. So we're raising it to the 2nd power and essentially taking the first root. Well, since the root is an odd number, we're only going to have one answer. And so our answer is just the number 25. It's not going to have 2 answers because we didn't have an even root. Okay, next problem. X is being raised to the fraction 4/3, and it equals 81. Now, how am I going to get my x alone? I'm going to raise this to what I'm going to call the reciprocal power. So I'm going to raise it to the 3/4. That's the reciprocal of 4/3. And before I forget, I'm going to do the same thing to the 81. We'll come back to the 81 in a minute. X raised to the 4/3 power and then raised again to the 3/4 power means we multiply the exponents. 4/3 times 3/4 is a 1. So I have x to the 1, or just plain x. All right, before I get to the 81, I want to think about how many answers am I going to have? Am I going to have 1 answer or am I going to have 2 answers? So I look at my root. Remember, the bottom number is the root you're taking. And what we did was take the 4th root. 4 is an even number. That means I'm going to have 2 answers. So I'm going to write myself a little reminder here. I'm going to put a plus or minus there to remind myself that I'm going to have a positive and a negative answer. All right, so we have x equals plus or minus 81 raised to the 3/4. Well, we need to simplify this big boy. We are taking remember this is the power. We're raising 81 to the 3rd power, and we're taking the 4th root of it. We have 2 jobs to do, and we can do them in either order. We can do 81, and we can raise it to the third power first, and then take the fourth root second, or we can take the fourth root of 81 first, and then raise it to the second power. Now, I actually like this way better, and the reason is, when you take the root first, you turn 81 into a smaller number. And I like dealing with smaller numbers. If we go up here and cube 81 first, we're going to get a humongous number that we're going to have to deal with, and we're going to have to grab our calculator. But lots of times, if you will take the root first, you'll get a small number, and a lot of these you can do in your head, because you turn it into a small number first and then raise it to the third power. Alright, so let's review. Here's where we are. I am going to put the plus or minus there to remind me. I'm going to take the fourth root of 81 first, and then I'm going to raise it to the third power. Alright? Now your calculator will take the fourth root of 81, and if you take the fourth root of 81, you will find that that's the number 3, because if you take 4 3s and multiply them all together, you get 81. I still have to cube my answer. I've taken the fourth root, but I haven't cubed it yet. So I have plus or minus 3, which I have to cube. And when you cube 3, you get a 27. So we have two answers, a positive and a negative 27, because we were taking an even numbered root, that 4 up here. Since the root we took was even, we get two answers. Okay, and of course they're going to make it a little more complicated. Here's your fence. We have multiple things on that side of the fence here. Now before we use our trick of raising this x, to its reciprocal power, 5 over 4, before we can do that, we need to get that x alone. So I need to get rid of the 4, and I need to get rid of the 27. So what order do I go in? I get rid of the one that's furthest from the x. So I'm going to get rid of the 27 first. Then I'm going to get rid of that 4 that's right next to it. And then finally, I'm going to raise that x to the 5/4 power to get rid of that exponent. Alright, so we added 27 here and here. Got rid of the 27. We divided both sides by 4 to get rid of the 4. And the last thing I need to do is get rid of that exponent, 4 over 5. Alright, you guys know what to do from here. To get rid of that exponent of 4 over 5, I raise it to its reciprocal, 5 over 4. So I'll do that to both sides. I get an x here. Alright, now, one answer or two. I got to ask myself, what root am I taking? 4 is even, so I'm taking an even root. That means I have two answers. So I'm going to put a little plus or minus there to remind myself I'm going to get two answers because I'm taking an even root. Alright, you guys know I like to take the root first. Whoops. So I take the fourth root of 16, and then I'm going to raise it to the 5th power. So x equals plus or minus, and the fourth root of 16 is going to be the number 2, because it takes 4 2's multiplied together to get 16. I have to raise the 2 to the 5th power, and x is going to be plus or minus 32. Two answers because we took an even root.